Hi, in this video, we'll be continuing the H2 Mathematics 2021 Paper 1. For question 10, it just tests you on differential equation and modeling. So what it means, we just need to read the question carefully and write down every information that we know. This will help us solve the modeling problem and allow us to easily grasp it. So the trick in this is to just read the sentence and write down the information. So the scientists model the number of bacteria by n, and you know the time is in t minutes. So now it assumes that the growth rate, meaning dn dt, is kn. So you just write dn dt kn for some k positive constant. And they tell you initial bacteria is this and time is that, but that can only help you solve the constants later on. And you should know that by practicing more. So we want to solve this differential. You divide the n over, keep the k there. You integrate 1 over n, integrate the k. The usual steps, variable separable. Then get ln n equals to kt plus c1. So the reason why I didn't put a modulus with this n is because the population size has to be positive already. So you don't need the modulus here. So you might ask how I get this. Well, what we now need to know is we want to have n. So we need to bring e. So this is now raised to power e. So it's ekt plus c1. But this is just ec1 times ekt by the indices rule. And ec1 is a constant, so we label it a. So you can straight away write this if you remember it well. Or you can just do what I did to help you derive it. So that is just, we just e. So now the ec1 is become a. So now it's a ekt, which is easier. So we let, when t equals to 0, n is 100. So a must be 100. So you see, you don't need to go find c now because ec is still just one constant. So just find a is enough. When t is 2, n is 300. So it's 300, 100. So you divide it over, you just get 3. Then you just imagine you ln 3 equals to 2k. So k equals to ln 3 over 2. Now, with the constants found, we have solved the differential equation and found k. So we want to find the time taken for it to reach 1000. Meaning when n is 1000, you just write out the formula with all the constants sub in, and then you solve for t. So you divide it over, which is 10, then you ln 10 equals to ln 3 over 2t. Then it times up, divide below. So it's this, and then you just make it in 3SF, which is 4.19. So t equals to 4.19 minutes. So I hope it's clear on how to solve a first order differential equation using variable separable. Next, the scientists now model it a different way, and they found that the growth rate is the same. So this is the growth rate, but now they have this bacteria dying rate. So you need to minus away this constant. And well, we are supposed to solve the differential equation giving t in terms of n and d. So in this case now, you cannot just divide by n because there's this constant. So you need to divide the whole thing. Then it will be 1 on the other side. When you integrate it, it's 1 over k ln. Now you need to put the modulus because you don't know whether it's positive or negative. And equals to t this. Again, now you just multiply k up, so it's k. And when you remove the e and the modulus, it will just be some constant a. That's why it's good to remember it so that you can straight away just write a. Then you don't bring the power e up, then think how to remove the modulus and stuff. Just straight away bring the power e, remove the modulus at the same time, put a ekt. When t is 0, now n is 100. So this portion over here is equals to a. Then when you sub it back in, it'll be like ln 3 over 2n minus d equals to this. E don't know what. E ln 3 over 2t, because you already found k earlier on. With that, you can divide this over, ln it, and divide by this, so you get this function of t. And so then you can use this function of t to find the function of fn as well. So now you have two functions, n and t, and that's what the question wants you to do. Next, we're supposed to find the range of d such that the bacteria will always decrease, I mean. So that means the dn dt must be decreasing, so it's negative. This just means kn minus d is less than 0. So d has to be actually greater than kn, which is equal to ln 3 over 2n. So that's the range of d that it must be. So that should be quite simple. Now when d is 58, we want to find the time taken. Well, d is 58, n must reach 0. Then you just sub into the formula and you get t equals to 5.35 3SF. So that's all for that question. Moving on to question 11, it's like an application of differentiation with a bit of mathematical modeling and understanding parametric equations. So they tell you that QR is modeled by this parametric equation, and at Q theta is beta and at R theta is 2 pi minus beta. So the first that you need to do is find P and S, which has the same x coordinate as Q and R respectively. So you just need to sub beta into the parametric to find the s coordinate for Q, which is then be the coordinate for P. As well, similarly for S, which you sub the coordinate for R. Then you just find the distance between them, so you just take this minus this. And you should be able to simplify it to get 2a times pi minus beta plus sine beta. And we want to now show that the area of the shaded region is some expression given. So the area of the shaded region is, you just need to integrate the parametric curve from beta to 2 pi minus beta. So integrating from beta to 2 pi minus beta of the height y dx. So this is the y. Now the dx you need to convert it to d theta. So you need to take dx d theta to convert it. So you write dx d theta, and then you can write in pencil dx equals to a minus a cosine theta d theta. But then you have to erase it because this is differential forms, which is not really necessary to write out, and it could be judged as wrong. But yeah, so you just cancel it out later on. Then you just have this, you cross multiply, then you get this. You can convert the dx now to this function, which we want the d theta, because in the end we want everything in theta since the limits are in theta. Then we just we pull out the a's, we expand out inside, so we get this. Always when you see cosine squared, you always just use double angle formula straight, and then you can simplify it, integrate it nicely now, sub in the values, and it will be very, very messy. So you just need to write it as clear as possible and ensure that there's no careless mistake, and you will get the expression that you want in the end. And the last few parts is that now we know that the area under the bridge is 7.8159 a squared, and we want to find the value of beta. Well, you just equate this area with equals to this, cancel out the a squareds, simplify it to get this equation now. Then you just plug this into your GC and see where the x-intercept is. So that's the beta. Next, the width of PS is 50 meters. Find the greatest and least length heights of the arc, QR. Well, if you look at the arc again, the least height must be at Q or R. So you just need to find the Y coordinate here lah. So you just sub in and you can find the least height very simply. So the least height will just be theta at Q. So that's the beta equals to something given over here. So you just sub in and find Y. As for the greatest height, well, we know that PS is now 50, so we can actually find A already. For the greatest height, you can first find the intersection O and C. Then you just take the symmetry. By symmetry, the greatest height is in the middle. So you find where is at O, which is at 0, and C, which is at pi equals to 2, theta equals to 2 pi. How to find that is you equate Y equals to 0 and solve for theta. So the greatest will be when theta equals to pi by symmetry. And then you just sub in and you should get 22.7 as the greatest height. So that's all for this paper. I hope you have enjoyed this series where I did the paper 1 for 2021. I'll be moving on to paper 2 in the next video. And so I'll catch you again. If you have any questions, leave it in the comments. And feel free to like, share and subscribe, as it will really help boost the channel to reach out to more audience that need help. Thanks. Bye.